Hi there, welcome to another video from Hegarty Maths. It's Mr. Hegarty here, our second video on direct algebraic proof. We're just going to continue where we left off previously and doing more complex examples. Just for a little warm up, you need to be super familiar with the type of algebraic terms we use to represent a number, an even number, an odd, consecutive numbers, consecutive evens, consecutive odds. Pause the video and double check you can remember that which we did in the last particular video. Well, hopefully you remembered it was something of the following. Any number we usually call n, an even we call 2n or 2m, an odd 2n add 1, 2m add 1, consecutive numbers n add 1, that type of thing, consecutive evens 2n, 2n add 2, and consecutive odds 2n add 1, 2n add 3. We're going to need that for this particular skill. Alright, let's give a go some more difficult proofs. Now, let's try and prove this. The difference, now remember difference means subtraction, between the squares of any two consecutive even numbers is twice the sum of the two numbers. Okay, let's just start off with, when it says is, that basically means equals, right? So if we can show the difference between the squares of any two consecutive even numbers, if we can work that out, and also we might want to work out 2 times the sum of the numbers, and if we showed the two things were the same, we'd have done the proof, right? So let's do that. The difference between the squares of any two consecutive even numbers. So as always, let n be a positive whole number. Then our two consecutive evens, we could say then 2n and 2n add 2 are consecutive evens. Okay, and we've done that type of thing before. Now, the difference between the squares of them, let's square them and take them away. Let's take the bigger one, so 2n add 2 all squared, and we're going to subtract 2n squared, and we're going to have to work this out. So this means 2n add 2 multiplied by 2n add 2 subtract 2n multiplied by 2n. Okay, you need to be good at expanding your brackets here. I'm going to do it in one move. So this is 2n times 2n is 4n squared, 2n times 2 is 4n, and this 2 times 2n is 4n, so it's going to be add 8n. I'm collecting like terms as I go, and 2 times 2 is 4. And then I'm going to subtract 2n times 2n, which is 4n squared. Now look what happens. That 4n squared and that negative 4n squared cancel, and we just get left with 8n add 4. Okay? Now, that is working out the first bit. Let's, in a different color, work out twice the sum of the two numbers. So let's separately do twice the sum of the two numbers. So here's one number, 2n add 2 add 2n. And let's work that out. So that's 2 times 2n add 2 add 2n is going to be 4n add 2. And if we times out that bracket, we get 8n add 4. Oh look, that is the same as that, and therefore we have proved what we wanted to. So we could say at the end therefore, and we should write out the difference between the squares of any two consecutive even numbers is twice the sum of the two. We should write therefore and copy out that as a true statement. I'm not going to do that here to save some time, but you should do that. Okay, let's try another one. Now this time we're asked for any 3 consecutive integers, right, the product, that means multiply, of the first and the third one is, now when you see is, this is a key word, that's equal, is 1 less than the square of the middle integer, the middle number integer. Okay, let's try and get an expression for the thing in yellow. Let's try and get an expression for the thing in blue, and let's try and show they're both the same. Okay, so 3 consecutive integers. Let's use our little trick. Let's let n be one of them, let's let n add 1 be another one, and let's let n take away 1 be another one. That's our little trick with consecutives, especially with 3. So let's start by saying let n be an integer. And then we can say that n subtract 1, n and n plus 1 are consecutive integers. That's definitely a true statement. Now what we're going to do is we're going to do the product of the first one and the third one. That's the first one and that's the third one, right? So let's do that. For step 1, let's call it the left hand side as it were, or the first bit. Let's do n subtract 1 multiplied by n add 1. We should know they're the difference of two squares, and that's n squared take away 1. Now let's try and do the right hand side, or the other side of it. 1 less than the square of the middle number. Well, the middle number is n. If we square that and we take away 1, yeah, look, we get n squared take away 1. And look, we've done that in one move just by being clever. That is equal to that. So therefore, we would have to write therefore, and then you should write for any three consecutive integers, the product of the first and the third is 1 less than the square of the middle number, and you're done. And we showed it then nice and quickly with algebra. Okay, one last example for us here. Prove that every line of this pattern always gives 3. Well, let's just think about this now. I'm going to call this the first line if you don't mind. That's the first line, that's the second line, and that's the third line. Now if you work it out, 2 times 4 is 8, 1 multiplied by 5 is 5, 8 take away 5 is 3. 3 times 5 is 15, 2 multiplied by 6 is 12, 15 take away 12 is 3. 4 multiplied by 6 is 24, 3 multiplied by 7 is 21, 24 take away 21 is 3. Now we know it's no good just keep on plugging in numbers here. We've got to do it with algebra. Now, the first line, that is the number 1. The second line, that is the number 2. The third line, that is the number 3. I think we can see a similarity there. This number is always 1 more than that number. This number 3 is 1 more than that number. This 4 is 1 more than that number. Okay? And more than that now, we can see that, you see this number here is 3 more than that number. This 5 is 3 more than that number. This 6 is 3 more than that number. And lastly, this one here, this 5 is 4 more than 1, 6 is 4 more than 2, and 7 is 4 more than 3. So let's think about the nth line for any number n. This number here, if that's 1, that's 1. If that's 2, that's 2. If that's 3, that's 3. If this is the nth line, that would be n, right? And you'd have your takeaway. Now, this number is always 4 more than that number, 4 more than that number, 4 more than that number. So this number here, we're going to multiply it by n add 4, which is 4 more than n. Now, this first number is always 1 more than n. So we're going to have n add 1 for this column. And this number is always 3 more than that number, so this number must be 3 more than n, which is n add 3. Now we've just got to do a bit of multiplying out. Let's multiply out this particular quadratic, and we'd get n squared add 3n add n add 3. And we're going to take away this multiplied out, which is going to be n squared add 4n. And remember, we're taking away our whole answer to that. So let's put a bracket around this and this to remind us we're doing this whole thing, take away this whole thing. Tidying this up here, we would get ourselves n squared add 4n add 3. And think of that as -1 there, and multiply out that bracket there. So we're going to take away n squared, we're going to take away 4n. Now we're going to be able to combine like terms, collect like terms. N squared take away n squared is no n squareds. 4n take away 4n is nothing. And look what we're left with, 3. Just as we wanted to show. And we've shown that in the nth line, for the general case, you get the answer 3. So we have proved that this is true. And that's it for this particular video. Thanks for watching.